All right, welcome to Unit 12, Day 1. We'll need our yellow Unit 12 packets from our envelope. And if you could flip that to page 1, and you'll need your calculators out as well. So in this unit, we're going to use the calculations that we learned in Unit 11, distance formula, midpoint formula, and slope formula, to do proofs. So on page 1, this type of proof, it's called a coordinate geometry proof. You know it's this type of proof if they give you points to plot. So in a coordinate geometry proof, the first thing you'll always do is you'll draw and label the graph. Then you're going to state which formula or formulas you use. So the distance, the midpoint, the slope. You do any calculations you need to do, and then you write a concluding statement at the end. So first off, a reminder from Unit 11, our distance formula, which comes from the Pythagorean theorem. We've got distance is equal to the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. If your square root doesn't come out nice, we do a menu number factor and we simplify that square root. So what can distance formula tell us? Well, it can tell us things about our sides. In a right triangle, we can use distance formula and then test out Pythagorean theorem. If Pythagorean theorem works, that means we have a right triangle. If you do distance formula and show in a triangle there's two sides that are congruent, that can tell us we have an isosceles triangle. If you want to show something's a parallelogram, you can do distance formula and show there's both pairs of opposite sides congruent, which would give us a parallelogram. Okay, make sure to be filling these in those boxes on bottom of page 1. A rhombus has 4 congruent sides, so we can use distance formula to show that all 4 sides are congruent. An isosceles trapezoid, we can show that it has those 2 congruent legs using the distance formula. Essentially what we are doing when we do the distance formula, we're showing that if they have equal length or distance, then our segments must be congruent. So anytime you want to do something with segment length in a coordinate geometry proof, you should be using the distance formula. So we're going to look at 4 examples of coordinate geometry proofs using the distance formula today in class. So if we could flip over to page 2. We start out, we have a triangle, they give us the coordinates, and we want to prove it as isosceles. So first thing we're going to do is we're going to plot the points. Now notice with our points, they're all in the first quadrant or on an axis. So I'm going to draw my axes like this to make sure we have plenty of space. Be sure to label your X and Y axis. And we'll plot each of our points. We got 0, 0, and we'll label it A. We've got 2, 3, we'll label that B. And we've got 4, 0, we'll label that C. And we'll connect it to make our triangle. So that's step 1 always, is to plot your points, draw the figure on your grid. Step 2 is to list whatever formula you want. Well, isosceles, we want to show that there's 2 congruent sides. If you want to show anything about sides being congruent, we should use distance formula. So we'll write out our distance formula. D is equal to x2 minus x1 all squared plus y2 minus y1 all squared. So now we'll move down to step 3. So we're going to do all of our actual calculations. And I just wrote the points there so I would have them on this slide. So for each of our different sides, maybe we'll start with AB. AB is going to be the square root. We'll do x2 minus x1. So I'm going to do maybe 2 minus 0 squared. The x value from B minus the x value from A. Plus, we got to be consistent now. Since we started with the 2 for x, we got to start with 3 for y. And then just put the part under the radical in the calculator. So we'll give you a moment to do that. Don't put the radical in, just the part that is under the radical. And we get 13 for that, so we get square root of 13. If you do square root of 13, that doesn't come out nice. 13 is prime, so when you do menu number factor, you'll just get back 13, so that's the best we can do. So then we'll do our other two. We'll do BC, so this will be square root. We could do 4 minus 2 all squared. Plus, if we started with 4, we got to start with 0. 0 minus 3 all squared. Again, take a moment, put the part that is under the radical in the calculator. Don't put the radical. So we get square root of 13 for that. So we've already got our two sides. Let's just, for practice, show you the third one. So for AC, maybe I'll take the 4 minus the 0 squared plus 0 minus 0 squared. Well, the 0 minus 0 squared, that's going to go away. 4 squared is 16. So we'll have square root of 16, and that does come out nice, which is 4. So step 3, you'll always do whatever calculations you need to do for the problem. And now we're going to summarize. So we just showed that there's two congruent sides using our distance formula. So we'll state what we found. So triangle ABC is isosceles. And then tell why. Because two congruent sides implies isosceles triangle. So all of our reasons from the earlier proofs come back into play in the summary. You tell what you found, and then tell why you know that to be true. So if we flip over to page 3, we'll look at number 2. And we'll start out by plotting so notice A is going to be in the third quadrant. B's got to go down 5 and C's got to go up 4. So make sure you draw your x-axis so we have some room for C to go all the way down to -5. So we have -4, -1 for A. 0, -5 for B. And 1, 4 for C. So that's step 1. Plot the points, draw the picture. So we want to show it's a right triangle. So we saw on page 1 that the way to show it's a right triangle that we know so far is to do the distance formula and then do Pythagorean theorem. If Pythagorean theorem checks out, then it must be a right triangle. So when we write our formula, formula is just distance formula. Square root of x2 minus x1 all squared plus y2 minus y1 all squared. So let's start with our calculations. We'll do AB. So we'll have -4 minus 0 squared. If we started with the -4, we got to start with -1 for the y's, minus a -5 all squared. Take a moment, put the part under the radical in your calculator, see what you get. Don't put the radical in, just the part under the radical. And we get 50. Nope, I take that back. That's later. We should get 32. Now, we can do a menu number factor to simplify that. But since we're going to put these in Pythagorean theorem, it's easier just to leave it as this for right now. Because then when we square them, it'll be easy to know what you get back, because it'll just be the number under the square root. So there's AB, so next we'll do BC. So we'll have square root, we'll have 0 minus 1 all squared, plus -5 minus 4 all squared. Take a moment to put the part under the radical in your calculator. And we should get, for under the radical, 82. And then our last one, CA, or AC, however you want to call it. We could do something like -4 minus 1 all squared plus. If you're starting with -4, then you got to start with the -1 minus 4 squared. And that was going to eventually give us square root of 50 when we put it in. So what we need to test now is Pythagorean theorem. So we need to identify which one's the hypotenuse. The hypotenuse has to be the largest, so that's the square root of 82. So we're going to do square root of 32 squared plus square root of 50 squared equals square root of 82 squared. When you square a square root, they wipe each other out, so we just get the number that's underneath. And really, we don't know if these are equal yet. That's what we're trying to figure out. 32 plus 50 is 82. So Pythagorean theorem does check out. So we're ready for our summary statement. We can say triangle ABC is right since Pythagorean theorem works. So the two we've seen so far, if you want to show an isosceles triangle, do distance formula of all three sides. Show that there's two congruent sides, which implies isosceles triangle. If you want to show there's a right triangle, do your distance formula of all three sides, put it into Pythagorean theorem, show it checks out, and that will allow you to conclude that it's a right triangle. All right, moving over to page 4. Take a moment, see if you can plot all of our points for our first step. And make sure to label those points. So ABCD, we want to show it's a parallelogram. We'll learn in this unit there's a number of ways to show a parallelogram, but today we're working with distance formula. So the way we can show that with distance formula is show that there's both pairs of opposite sides congruent, which would imply parallelogram. And we show congruent sides with our distance formula. So step 2, we always write our formula. x2 minus x1 all squared plus y2 minus y1 all squared. So we'll calculate each of our distances. So for AB, we'll start with an x value minus our other x value squared. Plus, then we'll start with the corresponding y value minus the other corresponding y value squared. Take a moment, punch the part under the radical in your calculator and see what you get. And we should get 13 under there, so square root of 13. If you do menu number factor, nothing simplifies there. So next we'll move to BC. So we'll start with an x value like -3 minus the other x value of 1 all squared. If we started with -3, we got to start with its y value of 4, minus the other y value of 5, square it. And you might be able to just do these in your head rather than putting them in the calculator. -3 minus 1 is -4. -4 squared is 16. Remember, when you square something, it should come back positive. 4 minus 5 is -1. -1 squared is 1. And when you do 16 plus 1, you get square root of 17. Again, if you did menu number factor, nothing would simplify there. If we keep going, CD, we're going to have 1 minus 3 squared plus 5 minus 2 squared. 1 minus 3 would give us -2. -2 squared is 4. 5 minus 2 is 3. 3 squared is 9. 4 and 9 will give us another square root of 13. So that's good news. And then finishing off with DA, we'll maybe start with the x value of 3 minus the y or x value of -1 squared. If we started with 3, we got to start with the y value of 2 minus 1 squared. The first parenthesis would give us 3 plus 1, so that's 4. 4 squared is 16. 2 minus 1 is 1. 1 squared is 1. 16 plus 1 gives us 17. So it looks like we're going to be in good shape. We just got to write our summary statement. First, tell what we can now conclude. We know that ABCD is a parallelogram. And then you should say either since or because. Either of those is fine. And then tell why. So since both pairs of opposite sides congruent implies a parallelogram. So plot your points, write the formula you're going to use, do your calculations, and in your summary statement tell what you determined and why. When you do the why, you should be using things from our previous proof units. All right, if we go over to page 5, one last one for this video. Take a moment, see if you can plot all your points. Now just note, our y values have to get up to 7 there. And there's no negative y values, so you probably want to put your x-axis pretty low to make sure we can get all the way up to 7 for your y values. So take a moment to plot those. So our goal with a rhombus is to use distance formula to show there's 4 congruent sides. So next we write our formula, x2 minus x1 all squared plus y2 minus y1 all squared. And we'll just do the distance for each of our sides. So we'll start with rs, x minus the other x value squared. If we started with -3, we then have to start with the y value of 2 minus 6 all squared. Well, that's going to end up as a +2. -3 plus 2 will give us -1. -1 squared is 1. 2 minus 6 is -4. -4 squared is 16. 1 plus 16 will give us square root of 17. If you do many number factor for that, just get 17 back because 17 is prime. So ST, we got square root -2 minus 2 all squared plus 6 minus 7 all squared. -2 minus 2 is -4. When you square that, you get 16. 6 minus 7 is -1. -1 squared gives us 1. 16 plus 1 gives us another square root of 17. So that's good. If we keep going, next we'll have TV. So that's 2 minus 1 all squared plus 7 minus 3 all squared. First parenthesis will give us a 1 squared, which is 1. Second parenthesis would give us a 4 squared, which is 16. 1 plus 16 gives us square root of 17. And the last one, VR. Maybe we'll start with r's x value of -3 minus 1 all squared. If we started with -3, we got to start with the y value of 2 minus v's y value of 3 all squared. -3 minus 1 gives us a -4. When we square it, we get 16. 2 minus 3 gives us a -1. When we square it, we get 1. 16 and 1 gives us square root of 17. So it looks like we're going to be in good shape. So we need to state what we found and why. So we found that RSTV is a rhombus. And then you should say either since or because. Since 4 congruent sides implies rhombus. So our 4 steps: plot the points on the grid and label them. Write your formula, which for today was just distance formula. Do any calculations you need. And then state what you found and why in the conclusion. So you've got the day 1 homework. Have a great rest of your day.